Okay, so we are talking about lesson 1.2, and the topic is limits. Okay, so this is, did any of you take AP Pre-Calc already? Okay, sometimes people took that before, but okay, so this is a brand new topic. I never talked about it in a math class before. All right, in football, any football players in here? No, we've all watched football though. If the length of a penalty exceeds half the distance to the offending team's goal line, then the ball is moved only half the distance to the goal line. Suppose one team has the ball at the other team's 10-yard line. The other team, in an effort to prevent a touchdown, repeatedly commits penalties. After the first penalty, the ball would be moved to the 5-yard line. After the second penalty, it would be moved to the 2.5-yard line. After the next penalty, the 1.25. Assuming penalties could continue indefinitely, which they can't, but let's assume that they could, would the ball technically ever cross the goal line? No. I mean, practically, yes, the football's big and it would look like it was crossing. But in technical terms, if you're going half the distance each time, you're never really going to get there, right? Similarly, if I had a Pop-Tart and I gave you half, and then I gave someone else half of that half, and then half of that, and then half of that, would I ever run out of Pop-Tart? Not technically, but practically I would, right? Okay, so that's what we're talking about. So technically the ball will never reach the goal line, but it will continually get closer and closer to the 0-yard line after each penalty. When a function approaches a numerical value, we call that value the limit. A limit may eventually be reached, or it may just get closer and closer, as is in the example of the football. Okay, so when we talk about limits, we are talking about what you are approaching. Whether you get to that value or not is irrelevant. And so we have to keep that in the back of our mind. What are we approaching? Okay, so in math we love symbols. Instead of writing things out, we like to condense it and use symbols. So here is such an example. Using symbols, this sentence right here would be read: the limit of f of x is a function or an equation, as x approaches a equals a. Okay, the limit of f of x as x approaches a equals L. Limits can exist from the left, from the right, and from both sides. Okay, so we're going to use this graph here, and I'm going to illustrate what is meant by a limit, and we're going to find all of these things to the right. Okay, so this is a piecewise, like you graphed for me yesterday. It consists of part of a parabola and part of a line. Okay, let's look at part A. This says the limit of f of x. Okay, this is the graph of f of x right here. Okay, I don't have the equation written out explicitly, but this is a graph of it. So I want the limit of this function as x approaches 0. Okay, so I'm going to go to the graph. And I'm going to find where x is 0, which is right there. Okay, I am going to look at this, and I'm coming in from both sides, closer and closer. I am traveling in from both sides, closer and closer to where x is 0. What is the y value approaching as x approaches 0? The y values are getting closer to 0. So I would say the limit is 0. Okay? So what this means is as the x's get closer to 0, the y value gets closer to 0. Okay? Part B, see this little negative after the 1? That means from the left. So in this case, I'm going to take this graph of f of x, and I'm only letting x approach 1 from the left-hand side. Okay, this is where x equals 1. That's where x equals 1. Okay, I am approaching that graph, so I'm dealing with this piece of the graph, not this one, because this one doesn't involve where x is 1. I'm approaching the graph from the left-hand side. I'm ignoring what happens on the right. I'm coming in just from the left. Can you tell what the y values are approaching? 1, looks like 2. Okay, so that limit would be 2. Okay, part C. Find the limit of this function approaching 1 from the right. Okay, so again, this is where x equals 1, but now I'm approaching it from the right-hand side. So I'm coming in not this way, but this way. And I'm getting closer and closer to where the x is 1. And what is the y approaching? 2 also. Just from above, whereas this approached 2 from underneath. Okay, so I'm going to jump to, oh, no, D is the next one I want. Notice that part D doesn't have the plus or the minus. When the plus or minus are not there, it means from both sides. Okay, so this means take this graph, let x approach 1 from both sides. What is y approaching? Well, from both sides, we know it's approaching 2. So the limit is 2. If these had been different answers, if from the left and from the right are approaching different numbers, then this limit would not exist. Okay? Any questions so far? It's only about what you're approaching. Okay, next one. F of 1. What am I asking you for there? Yeah, when x is 1, what is y? Okay, so I'm actually going to find the ordered pair on the graph where x is 1. Well, that's the same thing, isn't it? So when x is 1, y is 2. So here the limit and the actual value happen to be the same thing. That will not always be the case, as we'll see in a minute. Okay, part F. The limit of this function as x approaches 2 from the left. Okay, so now I'm no longer worried with x equals 1. Now I'm interested in where x equals 2, which is right here. Okay, but I want to approach it from the left. That means I'm only dealing with this parabola piece, because that is to the left. When I deal with to the right in part G, then I'll jump to this piece of the graph. Okay, so approaching from the left means I am coming in this way. And what is that y value approaching? 8. Even though when I get there, there's an open circle, that's okay. As I get closer to that point, those y values are getting closer to 8. Stop me at any time if you have a question. Okay, part G. Now I'm going to find the limit as x approaches 2 from the right. Okay, this is where x equals 2. And you can see on the right-hand side, now I'm dealing with this other piece of the graph. So now I'm coming in this way. What are those y values approaching? 3. Okay, part H. What is the limit as x approaches 2? No left or right there, which means from both sides. But if this side is approaching 8 and this side is approaching 3, they don't agree. So we say that at 2, the limit doesn't exist. And this is what we use. D, N, E. Does not exist. You can write out does not exist. You can write undefined, but usually I'll just use D and E for does not exist. They have to agree on both sides for the limit to exist there. What is f of 2? So when x is 2, what is the ordered pair on the graph? 3. That's where the closed circle is. I wouldn't use 8 because that's an open circle. There's not an ordered pair of 2, 8 on the graph, but there is an ordered pair 2, 3. So f of 2 is 3. Yes? No, not necessarily. Because, oh, for this one, yes. Yes. My bad. Okay, part J. the limit as x approaches 5 from the left. Okay, here is where x is 5. On the left is over here. So I'm coming in closer and closer and closer to where x is 5. And what's happening to those y values? They're getting closer to 0. Now I'm going to examine the limit as x approaches 5 from the right. This is where x equals 5. Approaching from the right, I'm doing this right here. And what are those y values getting closer to? 0. Therefore, the limit as x approaches 5 is 0. Because they agree, then that is the limit approaching 5. Who has a question? Not if you can have two different limits if you're examining from the left and from the right, but you can't, if the limit exists, you can't have two. See, when the limits are not the same from the left and right, then the limit doesn't exist. If they're the same, then the limit exists, and it's that one number. You can have them from the left, you can have them from the right, but to have them just from both, they have to agree. Okay? Next. Can we divide into 0? Can we divide by 0? Yes to one of them, both of them. No to one of them, both of them. What does that mean? Can we divide into 0? Okay, so think of this. If I had 0 freshly baked cookies for you, and I divided them equally, is that possible? No. Well, technically, can I divide 0 a number of ways? How much do all of you get? 0. 0. Sorry. Wish I had some. Okay, so this is yes. But can we divide by 0? No. That one is the no. Okay, so what that means is, yes, I can have 0 divided by 5. Or I could write it 0 divided by 5. Or I could write it old school, 0 divided by 5. That's okay. The answer in all cases is 0. Okay, we're going to look at why this is not the case in just a second. All right, you remember these words? Dividend, divisor, quotient? It's been a while, hasn't it? Okay, let's take this simple 18 divided by 6 equals 3. I could also write that as 18 divided by 6 equals 3. I could write that as 18 divided by 6 equals 3. All three of those mean the same thing. Okay, let's look at this old school way. 18 divided by 6 is 3. Which one of those is the dividend? 18. 18 is the dividend. Which one is the divisor? The 6. This is the divisor. And of course, then what is the quotient? Okay, kind of what we would call the answer, right? And then sometimes you have a remainder. In this case, we have a remainder of 0. Okay, so if I have a problem like this, and no remainder, then the divisor times the quotient should equal the dividend. 6 times 3 should equal 18. Okay, and similarly, if it's written as a fraction, 6 times 3 should equal 18. And there's my dividend, my divisor, my quotient. Okay, so let's go back and examine this. If I had 0 divided by 5 equals something, dividend, divisor, quotient. 0 divided up 5 ways evenly, everyone gets nothing. But this works out. Like this times this gives me that answer. Right? Quotient times divisor equals dividend. Just like 24 divided by 4 equals 6. 6 times 4 equals 24. Okay, now let's switch it. Let's say I have 10 and I want to divide it by 0. What can I put here so that this number times 0 gives me 10? Nothing. That's why division by 0 is undefined. It's a very simple reason. It just doesn't work. So there's no quantity I can put there. If I put 0 there, 0 times 0 is not 10. Nothing times 0 is going to give me 10. So this is not possible. And that is division by 0. I'm trying to divide by 0, or we say undefined. Okay, so that's fine. It's pretty simple. Just doesn't work. Divisor times quotient doesn't give me dividend. Okay, so I bring up all of that because we have to remember when we're dealing with functions with fractions that we can't divide by 0. So what happens here if I let x equal 3? I get a 0 in the denominator, which is undefined. Okay, so if x equals 3, I get 0 in denominator, which means undefined. Okay, so we're going to actually graph this, and maybe you haven't graphed anything like this before, but we're going to graph it. I'm going to show you how, but we have to remember that x can't be 3. Because if x is 3, this becomes 0, which makes the whole fraction undefined, because we'll have this situation, which doesn't work. Okay, so any ideas what that's going to look like? I mean, if I graphed x squared minus 9, that would be a parabola. But I'm dividing it by a linear quantity. So what's it going to look like? Any ideas? Anybody say parabola? Straight line? Any other guesses? All right, let's see. This is how I graph it. Do you notice that the top is a difference of 2 squares and can be factored? Okay. X squared minus 9 can be factored into x plus 3 and x minus 3. That's a pretty simple thing to factor. Again, that's called a difference of 2 squares. If I change that minus to a plus, then I couldn't factor it. But difference, subtraction, 2 perfect squares factors easily. Now, do you notice that there is a factor of x minus 3 top and bottom? I can cancel common factors in fractions. So if these are common factors are things that are multiplied, then I can cancel them. Just like if I had 2 times 3 divided by 3, those would cancel. Now, if it's 2 plus 3 divided by 3, those do not cancel. Those are not factors, that's a term. Okay, so common factors cancel. What's left here is x plus 3. Now, this is actually what my graph will look like. It will look like the line looks like y equals x plus 3. Well, we know how to graph that. That's easy. That's a line with a y-intercept of 3 and a slope of 1. But once I graph that line, I have to remember that I can't use 3. So what's going to happen is I'm going to have this line with a hole in it. You ever seen a line with a hole in it? Maybe not, but we have now. All right, let's graph this and look. Crosses the y-axis at positive 3. I'm going to use a pencil first. Y-intercept at 3. The slope is 1. Rise 1, run 1. So that's going to be my diagonal line. But I cannot use 3. So I'm going to go to where x is 3, follow it up to the graph, and that's where this open circle will be, a hole in the graph. But other than that, I want to graph that line. Oh, I should use my ruler. So that would be my step. Looks like a line, but technically there's a little hole that we have to jump over when you get to x equals 3. Okay, now if we graph that on a graphing calculator, let me just show you super quick on mine. You're not going to see the hole, so it's very deceiving. I think it just doesn't have the capability to do that. All my things set up here. Watch this. I do x squared minus 9 over x minus 3. It just looks like a line. Okay, so it's a little deceiving. We have to know that we can't use 3, makes it undefined. Therefore, we have to put that hole in the graph. Okay? This can be a reminder that the graph will look like a line, but it will definitely have that little gap in it. Okay, so now that we have it graphed, let's answer these questions. What is the limit as x approaches 3 from the left? Approaching 3 from the left. What's the limit? 6. Okay, an algebraic way of finding that answer is we can pull 3 into this. 3 plus 3 gives me 6. Okay, so that limit is 6. In case it was a fraction or something that was hard to evaluate. What about approaching 3 from the right, coming in this way? 6. Okay, what is the limit approaching 3? 6. What about the fact that there's a hole there? Doesn't matter. The limit is about what you are approaching. And coming in from both directions, we are approaching a y value of 6. Now, what is f of 3? Undefined. Or you could say does not exist. Because there is that open hole when I get to 3, but that doesn't affect the limit. Okay, we know that f of x is not continuous at x equals 3. Well, we knew it because we knew we put a hole there, right? So we have to jump over that. There's a discontinuity there. But this is like mathematically the reason why we know it's not continuous, because the limit and f of 3 are not the same. So that means we're not going through that number that the limit represents. Any questions?
What's the hole there?
Because, go back to your original function, I can't use x equals 3 because it gives me 0 in the denominator, which is undefined. Okay. Any other questions? All right. Okay, so these I've graphed for you. These are not ones that you would just naturally know what they look like, except maybe that step function there. Remember that step function we looked at yesterday? The +1 shifts it which way? Left 1. When it's inside the function, it kind of has that opposite effect. It'll go left to right, plus goes left, because -1 is what makes that 0. Okay, so these are not ones that you would just readily know off the top of your head what they look like. So here they are. These are the graphs. Okay, in this particular problem, example 3, I am looking for the limit as x approaches 0 from the left. Okay, this is where x equals 0. Okay, jot down what you think the limit approaching the left is. What did we get? 2. Nice. Now, before I just had an f of x there, this is just writing the equation in instead of using a generic f of x. Any questions on 2? Okay, let's just, for the fun of it, what is the limit approaching 0 from the right? Now, I'm going to use f of x, so I don't have to rewrite anything. Yeah, -2. And just for the fun of it, what is the limit as x approaches 0? Undefined or does not exist, because I'm approaching different numbers from the left and the right. They are not in agreement, so that does not exist. Okay on that? All right, next one. Here's our graph. Here's our function. And I want the limit as x approaches 3. Is that a negative, you think?
No.
I'm not sure. All right, we're gonna say it's a negative. I'm not 100% sure that was. Very faint if it's a plus. Okay, approaching from the left, what is my limit? 1. From the left, I'm coming in this way. Those y values are not only approaching 1, but they are 1. What about approaching from the right? -1. What about just approaching 1?
Undefined.
Undefined. Okay, or does not exist. Yes.
I'm kind of confused.
Okay.
I think like in general.
In general, okay.
Can you just explain it again?
Yes, so x approaches 3 from the left. So here, I'm going to put my yellow pencil where x is 3. Okay, if I'm approaching from the left, then I'm dealing with this piece of the function, totally ignoring this one, because this is on the left. So I am coming in from the left, getting closer and closer where x is 3. And what are these y values? +1. Okay, but what I said, let's write that down. The limit as x approaches 3 from the right of this function. Okay, this is where x equals 3. If I'm dealing with from the right, now I'm on this piece of the function. And so I'm coming in closer and closer from the right towards x equals 3. And those y values are all -1. And then because those are different, I would say the limit approaching 3 does not exist. Any other questions? Alrighty, here's our little lovely step function here. Okay, x approaches -2. From the left, right, both. Okay, come up with an answer for me. Approach -2 from both sides. See if you agree with your neighbor. Or someone behind you or in front of you. They want to volunteer their answer? Nobody? Okay, just shout it out. What'd you get? That was not a shout. Did we get does not exist? That would be right. If you got does not exist. Now, if I ask you for the limit from the left, that exists. Limit from the right, that exists. But from both directions, look. This is where x equals -2. Right here. If I'm coming in from the left, I'm on this step. If I'm coming in from the right, I'm on this step. Those y values are not the same. So that's why it does not exist. Questions? All right. Try this one for me. The limit approaching 3. Limit approaching 3. You might want to volunteer. What? Does not exist? 1. You might have a different answer than those two. Okay. All right. So we are approaching 3. This is where x is 3. I am approaching from the left. What are those y values getting close to? Okay. I am approaching from the right. What are the y values getting close to? Are they the same? Yep. Limit is. Now, what trips you up here is that you say, yeah, but there's an open circle when I get there. That's okay. The limit is only dealing with what you approach. Even if it's not there when you get there, it's about what you're approaching. Now, what if I said, what is f of 3? It does exist. It is 5. Because there is an ordered pair, 3, 5. And this is when it gets a little confusing. So f of 3 is 5 because of that dot. The limit approaching 3 is 1, despite the open circle. Is this a continuous function? No, because those are not the same. I'm approaching 1, but when I get there, that point's undefined, right? I've got this point hanging out in space up here. So it's a discontinuous graph because it doesn't go straight. There's that little break in it. Okay? All right, so that's it for the notes. I have a quick little piece. Let's go with your computers. Okay. Get your computers. I have a quick little, I can't remember, is it a booklet? And then I'll give you your homework to do.